Welcome to a webcast made by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Vectors series and concerns basics of vectors. This guide introduces vectors and some of the language that describes them. It defines the magnitude of a vector and how to calculate it. It also introduces unit vectors. Introduction. Vectors are a very important idea in all areas of science. For example, most of modern physics relies on vectors and the theory that surrounds them. A vector can be thought of as describing a journey from one point to another, and in fact the word vector comes from the Latin for passenger or carrier. They are usually drawn as a straight arrow joining 2 points, with the arrow showing the direction of travel. For example, the diagram shows two vectors, one which goes from point A to point B, and one which goes from C to D. In mathematics, these journeys are written as A to B and C to D. For vectors, the direction is very important. For example, the journey from B to A, written BA, and also the journey from D to C, written DC, is a different but related vector. You should also see that the distance from A to B is the same as the distance from B to A, and this is not a vector. In mathematics, something which has a magnitude but not a direction is called a scalar. Vectors and scalars are related but different. Vectors have magnitude and direction. Scalars have only magnitude. Vectors and scalars. It is crucial that you understand the difference between a vector and a scalar. You can use the number line to help you understand this difference. Take the vector A to B above. If A is on the number line at 2 and B is on the number line at 5, then the distance between them is 5 minus 2, which equals 3, and this is a scalar. In fact, all numbers are scalars. Here is the vector A to B illustrated on the number line. A is at 2 and B is at 5, and the vector spans from 2 to 5. You can also think of the number line as steps of length 1 from left to right. If you think carefully, each of these steps is a vector. In mathematics, a vector is typed in bold. If you are writing a vector by hand, you should underline it. Let's call the single step along the number line V for vector. So you can redraw the line as this. Each use of the vector V takes us one step further along the number line. Here you can see we can go from 0 to 1. And here from 4 to 5. So travelling from A to B, from 2 to 5, uses the vector V 3 times. Like this. You can write that A to B equals V plus V plus V, which equals 3V. You can think of the scalar distance 3 as scaling the vector V to create the journey A to B. Now think about B to A. This is the same as A to B, but in the opposite direction. You need to be careful with this idea. B to A and A to B are of equal length, but are not the same vector. One step along the journey A to B is V. To move one step in the opposite direction, the vector is minus V. For any vector V, the reverse journey is defined as minus V. So, travelling from B to A uses the vector minus V 3 times, as shown on the diagram above. So you can write B to A equals minus V plus minus V plus minus V, which equals 3 lots of minus V, which equals minus 3V. Although technically 3 lots of minus V is correct, you should write it as minus 3V, following the Snalphabet system. See study guide, Snalphabet. The magnitude of a vector. A special property of a vector is its magnitude. Rather than talking about the length of a vector, which seems natural, you should actually talk about its magnitude. The magnitude of a vector is always positive. In the example above, the magnitude of both AB and B to A is 3. In mathematics you will see the magnitude of a vector v written in a variety of ways. The most common is this, but you may also see this. In the example above, the magnitude of v is 1, which is written as this or this. This guide and other guides in this series uses this notation instead of any other. The idea of a magnitude is very important and will be more formally defined later in this guide. Unit vectors. Vectors which have a magnitude equal to 1 have a special name. They are known as unit vectors. In mathematics, the number 1 is often referred to as the unit. Any unit vector is given a special symbol. You write the vector with a hat on it. For example, as we have seen above, v has a magnitude of 1 and so is written as this, pronounced v hat. You can express any vector, for example a, as its magnitude multiplied by its corresponding unit vector, a hat. Mathematically this is written as a equals the magnitude of a multiplied by a hat. Remember that the magnitude of a is a scalar quantity. The idea of a unit vector is very important as you can use it to describe three-dimensional space as discussed in the next section of this guide. Spaces and dimensions. Earlier you saw that the vectors v and minus v could be used to move left and right along the number line. You can think of the number line as the x-axis, the horizontal axis. Then this is an example of a one-dimensional vector space, 1D, in that you can only move left or right along the x-axis. By adding the ability to move up and down, your space becomes two-dimensional, 2D, and you can move along the y-axis. It is important that the x and y axes are at right angles to each other. Finally, you can add a third axis, the z-axis, which is at right angles to the other two, which moves you in and out of the page. This makes three-dimensional 3D space. These three axes form a vector space. Usually in mathematics you will work in either two or three-dimensional space. At the centre of the space is a point where the axes meet, and this is known as the origin. Every point in 3D space has a coordinate which describes where it is in relation to the origin. In order to get to a particular point in the space from the origin, you can take steps along the directions of each axis. The origin has the coordinate 0, 0, 0, as you take no steps in any direction to get there. If you want to get to the coordinate 1, 2, 3, you take one step in the positive x direction, 2 steps in the positive y direction, and 3 steps in the positive z direction. Similarly, if you want to get to the point -2, 0, 6, you take 2 steps in the negative x direction, 0 steps in the y direction, and 6 steps in the positive z direction, and so on. The idea of taking single steps can be exploited by defining single steps along the retrospective axes as vectors. Then you can use them to reach points in space. These vectors are called the rectangular unit vectors and are described as I, the unit vector, a single step in the positive x direction. J, the unit vector, a single step in the positive y direction. K, the unit vector, a single step in the positive z direction. The rectangular unit vectors are at right angles to each other. This is called orthogonal, and they each have a magnitude of 1. Example: use the rectangular unit vectors to describe how to get from the origin to the points 1, 1, 2, 3, and 2, -2, 0, 6. 1. As mentioned above, if you want to get to the point 1, 2, 3, you take one step in the positive x direction, which is the same as 1i, or simply I, 2 steps in the positive y direction, which is the same as 2j, 3 steps in the positive z direction, which is the same as 3k. To write this as a vector, you must describe the journey from the origin to 1, 2, 3. This is one step in the positive x direction, I, followed by 2 steps in the positive y direction, which is 2j, and finally 3 steps in the positive z direction, 3k. You can write this idea as a vector. Let's call it A as vector A equals I plus 2j plus 3k. The vector A neatly describes the journey from the origin to the point 1, 2, 3 as a vector. It is convention to write the steps in the x direction first, followed by those in the y direction, and finally those in the z direction. You should get used to seeing vectors written in this format, as it is the most common way that they are presented. 2. As mentioned above, if you want to get to the point -2, 0, 6, you take 2 steps in the negative x direction, which is the same as -2i, no steps in the y direction, which is the same as 0j, and 6 steps in the positive z direction, which is the same as 6k. To write this as a vector, you must describe the journey from the origin to -2, 0, 6. This is 2 steps in the negative x direction, -2i, followed by no steps in the y direction, which is 0j, and finally 6 steps in the positive z direction, 6k. You can write this idea as a vector. Let's call it B as vector B equals -2i plus 0j plus 6k, which is equal to -2i plus 6k. If a vector occurs 0 times, such as j in this example, it is fine to miss it out, but you should remember that it occurs 0 times. It is very common for a general vector to be written in terms of I, j and k. For example, a general vector A is often written as vector A equals A1i plus A2j plus A3k, where A1 is the number of steps in the x direction, A2 is the number of steps in the y direction, and A3 the number of steps in the z direction. The magnitude of a vector, revisited. You can use the values of A1, A2 and A3 in conjunction with Pythagoras' theorem, see study guide Pythagoras' theorem, to define the magnitude of a vector as the magnitude of A equals the square root of A1 squared plus A2 squared plus A3 squared. You should always take the positive square root in this equation. Remember that you are squaring A1, A2 and A3, and that the square of a number is always positive. Because of this, a magnitude is always positive and never negative. You can use the equation above to write the corresponding unit vector of A, which is A hat. By rearranging A equals the magnitude of A multiplied by A hat, you find A hat equals A divided by the magnitude of A. By replacing A with A1i plus A2j plus A3k, you get A hat equals A1i plus A2j plus A3k, all divided by the magnitude of A. It is the convention when writing a vector to break it down into 3 terms, each comprising a scalar and either I, j and k. And so a more correct way of writing A hat is A hat equals A1 divided by the magnitude of A times I plus A2 divided by the magnitude of A times j plus A3 divided by the magnitude of A times k. Example: what are the magnitudes and the corresponding unit vectors of the vectors 1, b equals I plus 2j plus 3k, and 2, c equals -2i plus 6k. For the vector b equals I plus 2j plus 3k, b1 equals 1, b2 equals 2, and b3 equals 3. Using these values in the equation for the magnitude of b equals the square root of b1 squared plus b2 squared plus b3 squared gives the magnitude of b equals the square root of 1 squared plus 2 squared plus 3 squared, which equals the square root of 1 plus 4 plus 9, which equals the square root of 14. So the magnitude or length of B is the square root of 14, which equals 3.74 to 2 decimal places. The unit vector of B is B hat equals B1 divided by the magnitude of BI plus B2 divided by the magnitude of BJ plus B3 divided by the magnitude of BK, which equals 1 over root 14I plus 2 over root 14J plus 3 over root 14K. You can always check your answer for a unit vector as correct by showing the magnitude of the vector as 1. So here the magnitude of B hat equals the square root of 1 over root 14 squared plus 2 over root 14 squared plus 3 over root 14 squared, which equals the square root of 1 over 14 plus 4 over 14 plus 9 over 14, which equals the square root of 1 over 1, which is 1. 2. For the vector C equals minus 2I plus 6k, C1 equals 2, C2 equals 0, and C3 equals 6. Using these values in the equation for the magnitude of C equals the square root of C1 squared plus C2 squared plus C3 squared gives the magnitude of C equals the square root of minus 2 squared plus 0 squared plus 6 squared, which equals the square root of 4 plus 0 plus 36, which equals to the square root of 40. So the magnitude or length of C is the square root of 40, which equals 6.32 to 2 decimal places. The unit vector of C is unit vector of C equals C1 over the magnitude of Ci plus C2 over the magnitude of Cj plus C3 over the magnitude of Ck, which equals minus 2 over root 40I plus 0 over root 40j plus 6 over root 40k, which equals minus 2 over root 40I plus minus 6 over root 40k. Further guidance and information. If you have any further questions about mathematical skills or would like to discuss any other aspects of mathematics, you can talk to your lecturer or personal advisor or make an appointment to see a learning enhancement tutor in the Dean of Students office. You can telephone 01603 592761, email dos.help@uea.ac.uk, or visit our website at www.uea.ac.uk/dos/let. There are further resources on many other aspects of numeracy, mathematics, statistics and science available from the Dean of Students office and on its website. These include questions to practice, model solutions and webcasts illustrating essential skills. This guidance is one of a series on mathematics produced by the Dean of Students office at the University of East Anglia.